Okay. That was painful. Um, yeah, that was really painful. That was a painful experience. Let me share this. Okay, that should be good. Also, we. Okay. So, I was running into some issues with OBS. Um, Yesterday's stream was fine. Everything worked perfectly. But I've come to realize that display link, the hardware that I'm using to have a dual monitor setup, it does not like Linux in general, and now I've learned that it does not like OBS. I was running into so many seg faults that it's not even a joke. I published an issue, but after publishing the issue, I was able to figure it out by unplugging the display link, running OBS, and then reconnecting it, and then sharing my screen. It was an entire process. I'm probably gonna have to do it again, just because of display link having really bad drivers. So it's probably some detection issue. Couldn't detect some things, so it probably seg faulted when it couldn't find this module. But yeah, that was crappy. I did not like that at all. But anyways, today marks day 2 of the Odin Project. Yesterday I said that I would do each section per day, but today we're just gonna do prerequisites and then they get basics together. So tomorrow we will do HTML foundations and so forth. So let's just go ahead and start. So prerequisites, computer basics. Do I really have to? Okay, well, needless to say, whilst learning to code, you'll be spending most of your time on a computer. Hence, understanding how to work with your computer is crucial. In this lesson, we'll introduce a resource which will quickly get you up to speed with some computer basics. Computer software and hardware, how to take screenshots. Okay, that. Oh wait, did they? Oh shoot. Okay, are we still here? I just ruined the entire live stream. Oh man, I accidentally made a TTY, pressing the wrong keyboard shortcuts. That would have been bad. But yeah, we're still good. Okay, so it seems like I don't know how to take a screenshot. They might have changed it on me. Ubuntu screenshot keyboard shortcut. Alt. I'm gonna try this again. That does not work. Huh. They changed it on me. Okay, so let's go here. Take a screenshot. Okay, so we need to how to add shortcuts to Ubuntu. Select custom shortcuts. Oh, let's make sure. Command. I don't know. I don't know the tool. I do not know the tool for it. Probably not import. GNOME screenshots. What's this one called though? Let's see, 2023. Or we could say this one's weird. because if this is print, that just focuses on that. So I would have to install GNOME Screenshot, even though it would be a different software. Okay, that's fine. And then it should be right here, screenshot. Yeah, it's a totally different one. Then we just have to say GNOME. F10. It's right here too. Shift print. But that doesn't work. It just recognizes it as GNOME Screenshot. So it just took like 3 screenshots. I think I have to so it's there, it just doesn't exist. So does this work? None of my media keys work. So I have to probably install something. F10. So if I do Shift F10, okay, so I'm gonna fix this after the live stream. But yeah, this is all part of the reason why, or not the reason why, but when I wiped out my operating system, I originally had a developer. So prior to the wipeout, I had a developer edition XPS. And I guess that the developer edition configured everything for me so I wouldn't have to run into these issues. Good thing I backed it up, so all I have to do is just get my hard drive and figure out where they edit those files. Oh man, that sucks though. I can't play, pause, anything. I'm gonna have to figure that out. Okay. What is a computer? What is an operating system? What is an application? Open source versus closed source. You know what? Even though I know the information, it doesn't hurt to learn about it. I don't really like videos; they're too slow. But yeah, a computer is an electronic device that manipulates information or data. It has the ability to store, retrieve, and process data. You may already know that you can use a computer to type documents, send emails, play games, and browse the web. You can also use it to edit or create spreadsheets, presentations, and even videos. Hardware versus software. Hardware is any part of your computer that has a physical structure, such as a keyboard or mouse. It also includes all the computer's internal parts, which you can see in the image below. So yeah, that's things like your motherboard, your RAM, SSD, or your hard drive, the keyboard, the mouse, as I said, your graphics card, your processor, your Wi-Fi card. All that is hardware, and we use software to manipulate the hardware to be useful. Software is any set of instructions that tells the hardware what to do and how to do it. You see, without software, hardware would be useless unless it was like some... I'm not sure. All I would say is, yeah, without software, hardware is useless. Everything you do on your computer will rely on both hardware and software. For example, right now you may be viewing this lesson in a web browser, software, and you're using your mouse, hardware, to click from page to page. As you learn about different types of computers, ask yourself about the differences in their hardware. As you progress through this tutorial, you'll see what different types of computers also often use different types of software. What are different types of computers? But yeah, computers come in different shapes and sizes, and they perform many different functions in their daily life. When you withdraw cash from ATM, scan groceries at the store, or use a calculator, you're using a type of computer. Yep. Desktop computer, laptop computers, tablet computers, servers. Actually, there's some Raspberry Pis that are finally in stock. So, hallelujah. I can finally start ordering some Raspberry Pis and start working on my Raspberry Pi cluster. I just have to order some parts like the rack, and I can actually start building it. So finally, a server is a computer that serves up information to other computers on a network. For example, whenever you use the internet, you're looking at something that's stored on a server. Many businesses also use local file servers to store and share files internally. That would be called a FTP server or a SFTP server. It's just for file sharing. But yeah, another way you could explain is that a server is just a computer that's on 24/7. It's a special type of computer. For instance, there's you could build a Minecraft server that's on 24/7 that other people could connect to. All you would need is just a IP address and its port number, so you could start playing Minecraft. I think the port number for Minecraft is some 4-digit number. Yeah, 25565. Smartphones, yes, they're computers. Wearables like a smartwatch, computers. Game console, it's a computer. TV or smart TVs, a computer. This type of computer began with the original IBM PC that was introduced in 1981. Other companies began creating similar computers, which were called IBM PC compatible, often shortened to PC. Today, this is the most common type of personal computer, and it typically includes a Microsoft Windows operating system. I like how they didn't include Linux, because they're like, well, if you're using Linux, why are you here? The Macintosh. Oh yeah, and that reminds me. Let me. I won't go over this. This is pretty much self-explanatory. Holy crap, this is a long lesson. Wow, this is a really long lesson. Oh Lord, okay. It just keeps on going. 7 lessons. Wait, really? That's crazy. Good thing I have a general idea. So I think I can safely skip this one. Okay, operating systems. An operating system is the most important software that runs on a computer. It manages the computer's memory and processes as well as all of its software and hardware. It also allows you to communicate with a computer without knowing how to speak the computer's language. Without an operating system, a computer is useless. I agree. I agree with that. I actually want to build an operating system on a RISC-V processor. I think it'll be pretty fun to actually like figure out how to handle Semaphores, concurrency aspect, all the hardware stuff, paging, just memory. I think that'd be pretty interesting and a really difficult project to tackle, but overall pretty fun. Let's watch a YouTube video. Let's see what this is about. Yeah, I do not like videos. Is it though? Wouldn't that... I guess it is an operating system. I call it the kernel though, which is, I guess, an operating system. I guess it's interchangeable. Simply put, an app is a type of software that allows you to perform certain tasks for desktop or laptop computers, sometimes called desktop applications, while those are called mobile apps. Huh, okay. I never knew that it was called multitasking. I've heard this term before, but with CPUs, like a single core CPU, but you can do multiple things at once. It's multitasking. Okay, now we're getting to the nice part. I like this. Open source versus closed source software. Almost every piece of computer software is created using source code, which is a technical blueprint that tells a program how to function. When creators release their finished product to the public, they must decide whether to make its code open source or closed source. Watch the video below to learn more about how open source and closed source, blah, 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 blah. With closed source software, also known as proprietary software, I've never heard someone say closed source. They always say proprietary software. It's proprietary software. Don't use it. Proprietary software. A good example of open source and proprietary software is Mac OS, which would be a closed source, and Linux being open source. Like, I can go on GitHub right now and look at the source code for Linux. I could look at it. I can look at all of it. Wow, here's the source code for Linux. Crazy. Now, let's do the same thing for Mac OS. Nada. You're not going to see it. You're going to have to pay, and you still won't be able to see the source code. You'll just be able to use it. Closed source software is more likely to be stable, focused product, and if you need customer support if you need support, customer service is typically easier to access. However, closed source software often costs money, and if it has any bugs or missing feature, you'll have to wait on the creator to adjust the problem. I'm more of a open source guy. Like, I love using open source. Well, here's the problem. I'm thinking about selling my current computer, which is a Dell XPS 13 Developer Edition running Ubuntu, and getting a Mac OS 14-inch M2 Pro Max chip. Solely because I need to start developing some iOS apps. I hate that Apple gatekeeps you from developing any apps on their platform if you don't have a Mac or an iPad product. And you may be wondering, well, just get the Mini Pro. And yeah, I thought about that, and it's way cheaper. And it's honestly a valuable option, but I think I may do the switch because I want to move away from Linux temporarily and experiment with other operating systems and, just have general fun. I don't really hate Apple as much as non-Apple fanboys, but I do like their products. So, yeah, that may be something in the future. I'm still thinking about it, but we'll see. I'm going to skip this because what the heck. I can't even do it, so it doesn't even matter. Creating a strong password. This is what I use, Bitwarden, and I have it generate passwords for me. Long passwords that no one can break into, so there's that. I'm even thinking about hosting my own Bitwarden server using the Rust version. So there's that. They don't even actually, this site doesn't even teach you about salting or anything. Like, these are not good passwords. Okay, is Windows is an operating system? What's the difference? Okay, I already explained that. Say that you have a bug that you want to report, and then it needs to be visual. It's not really code, like some UI. You can just take a screenshot. Give an example of a weak and strong. So weak would be password. and we can see that from the rock you list. And a strong password would be something like this. This would be a really hard password, especially if you had symbols. Yeah, you're gonna need a supercomputer, a quantum computer. Okay, that's done. Accessibility. Ooh, maybe this will teach me something. More Mac stuff. I already know about this. Okay, next lesson. How does the web work? Okay, perfect. Now this will be, or give me a refresher. So we're gonna spend some time on this one. Drink some water. Okay. Just to make sure where I'm at. Installation overview. Oh, okay. Why does it say Heroku? Heroku is no longer free. Oh, okay. I've already done this. I've already done this. What are some things I can just skip? I already have this book. I'll go through this one, but I won't be going through the get stuff because I've already set that up. I've already pushed some things, and yeah, this is all good. Okay, so I can do that, do this, do this, do this. And then introduction, get basics. What does this have? Yeah, I don't think I need this because I do this all the time. We're flying through this. Okay, I guess we'll just keep these two. Okay. We've already got this set up and that, so I already have the knowledge to do that. I already have my terminal. I have my text editor installed. I have get installed already. If you go to projects, I can go to git log. Oh. Scribble. Yeah. I've already done commits. I've done all of that. So all of that would be a waste of time for me. Let's see. Okay. Before you can understand how to program the web, you need a more rigorous understanding of how the web itself than you likely have now. These concepts provide a more holistic understanding of the ecosystem in which you will be working and will enable you to talk intelligently with other developers about your work. Describe what the internet is. Describe what packets. What? We're actually learning about packets? Okay. Are we going to talk about TCP/IP, the OSI layers? Probably not. Maybe. Actually, maybe. We might. Okay. Okay, I think I'm gonna have to connect to my... Okay, does that mess up my audio? Hello, hello, testing. Oh, that's ARPANET. Oh, no, isn't that... Yeah, that's him. I did not know his name, but yeah, that's the guy. So, do you see how he said a network of networks? That is extremely important. Because that's what the internet is comprised of. All of us that are on our own network joins in together with other networks so packets can travel across the network. That's how I can send an email to my buddy in Japan. I don't have a buddy in Japan, but hypothetically, I could. That animation was a perfect example of how it works. Well, not 100% accurate, but I need to watch that again. That's how good that was. I wish it would have included like DNS, like the HTTP request that happens when you do click on that. And I also wish it would have shown like YouTube or Google servers that has the image hosted on their platform. But that's fine because we're going to learn about DNS. Oh man, this video brings back memories because I never understood what he was saying, but now I do. Okay, let's take a little 5-minute break. And then I'll talk about what they discussed to my best of my ability. Oh boy. Oh, that was a good stretch. Okay. Uh, 25 minutes is a little too short for me. I think we could actually we'll just do one more. Okay, so in this video, they were essentially explaining how a user can send or request some information. Say that the user wanted to send a message to Joe. So John sends a message to Joe. He says hi. Once he clicks send, that request goes through, we'll say that you're using the Apple product. It goes through the internet, which is just a network of networks. This packet, it's an encrypted package. It will go through the network, another network, another network. It'll probably split off into other packets, but they're all conjoined together when they reach their destination. They'll go through Apple servers and then go out the other end until they reach Joe. Joe will receive the message, and we have successfully completed sending a message. That's essentially what the video was about. We just have to think about the internet as a graph of multiple nodes that all conjoin together. So let's read about this one. Oh, this is a good example right here. Here's a graph. Oh, no, I think, the video also said that the internet and the web are not the same thing. That's true. The World Wide Web is basically just links that represents another graph, because you click on this link, that link will have other links, and those other links will have other links that could also loop back to original link or go to some other website. It's the World Wide Web. It's just links everywhere. That A tag, that is actually a very powerful element that if we didn't have, there would be no web. Internet is a way of connecting computers all together and ensure that whatever happens, they find a way to stay connected. Yeah, that's the goal of the internet. How can we find a way to have computers talk to each other so they're not so lonely? Deeper dive. I've never seen two computers linked together physically. I would actually want to experiment with that, because we usually see like computers talk to each other by Wi-Fi. So I think it'd be pretty useful to experiment, like how does a computer talk to each other using that Ethernet cord. And would it still work if I wasn't connected to any Wi-Fi? Like, what if I had just a laptop, two laptops, and they just had an Ethernet cord connected to each other, would it still be possible to send something to the other computer if I wasn't connected to the Wi-Fi just by an Ethernet cable? What would that look like? Huh. It's crazy. To solve this problem. So they're saying that, sure, we can have an Ethernet cable connected to computers, but what if we wanted to scale up? We wanted more computers. Well, we actually need way more Ethernet cables so every computer could talk to each other. This computer needs to be able to talk to this one, this one, this one, this one, this one, all of these. This one needs to talk to all of this. This one needs to talk to all of this. You need a lot of cables and a lot of ports for your computer. So instead of doing all of this, which will get hectic fast, we use a router. The router only has one job. It's like a signaler at a railway station. It makes sure that a message sent from a given computer arrives at the right destination computer. I enjoy this a lot. Human beings have, you can see it from the start. Human beings solve problems when they arrive. They probably said, oh, Ethernet cables are a mess. There has to be a better way. And then they did the same thing for computer graphics. Software renderers are slow. Let's make some hardware to make it faster. And that's what they did. That's why we have GPUs now. It's really fascinating. To send a message to computer B, computer A must send the message to the router, which in turn forwards the message to computer B and makes sure the message is not delivered to computer C. So this is probably something I would have to do, kinda, in terms of my Raspberry cluster. But switch is not a router. Switches facilitate the sharing of resources by connecting together all the devices, including computers. So the router allows you to connect to the internet. Switch is just a way to have multiple computers work together, or to know of each other's existence, like a router. But I'm sure that they serve different purposes. Okay. I don't know if this is a good example, but the purpose of a router is to let you connect multiple devices to a single internet connection and create a LAN. while switches only connect devices locally. So their analogy is that the router is a way to direct traffic. Computer B wants to send a message to computer I. So we send a packet, or we send a message. The router says, oh, well, this is supposed to go to computer I. It doesn't say, oh, I'm going to send it to everyone like a hub. It just says, hey, I'm going to send it to I. That's what it's doing. It's directing traffic on a LAN. This is an interesting diagram. A router is really just a computer. So what's stopping us from joining another router? Like, this makes sense. These are all computers. It's just, this is a computer with a specialized mission or objective. Connecting other computers to the internet and routing packets to the right computer. That's why it's called a router, because it routes. A modem. To connect our network to the telephone infrastructure, we need a special piece of equipment called a modem. This modem turns the information from our network into information manageable by the telephone infrastructure and vice versa. Yeah. Okay. I was thinking, like, wait, a modem. But yeah, my network has a modem. I mean, every freaking network has a modem. Gotta have one, it seems. Because that is what allows us to connect to a telephone infrastructure. The modem turns information from our network into information manageable by the telephone infrastructure and vice versa. An ISP is a company that manages some special routers that are all linked together and can also access other ISP routers. So the message from our network is carried through the network of ISP networks to the destination network. The internet consists of this whole infrastructure as networks. So here's our router, or here's our computers that are connected to our router. The router sends this information to the modem. The modem then sends this information to our ISP provider, or just ISP. And the ISP can also communicate with other ISPs. and then say that the message that we want needs to go over here in this network. Well, the ISP will send it to here, to ISP1, back to the modem, back to the router, and send it to whichever computer it was supposed to go to. Oh yeah, that's true. So we could talk to a computer right now. We've sent a request to a computer at Google, and it sent us something back as a response. HTML. IPv4. Why are we using that? Come on, man. Let's move to IPv6. Let's do it. Yeah, this makes perfect sense. Without the internet, there would be no web. The web depends on the internet in order to send stuff. Like, say that I click a link. I click on youtube.com. My computer sends something, sends a packet or a request, goes through this DNS, blah, 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 ISP, or modem ISP, goes here, YouTube servers. Oh, the server's like, okay, this person wants to get on this web page. Sends it back, modem to the ISP, internet, back to this ISP, modem here, boom, it gets this link as a response. Because the browser will parse through the HTML, the CSS, and the JavaScript and create the page, those documents, because that's what the user requested. IRC. Oh man, if I was a kid again and I had a computer, I would definitely just get join like an IRC chat, because that was like the early day Discord, talking with strangers. Hey, teach me how to code. Intranets and extranets. I've never heard of this term before. Extranets. Intranets are private networks that are restricted to members of a particular organization. It's not just a LAN. Well, no. I guess you could think of an intranet as when you're aboard in a plane and you're finally in the air, you can connect to the Wi-Fi. I think that would be an intranet. You have multiple people, and it's restricted because you have to pay for it. So let's look at examples of intranet. Obviously, any company would have their own intranet. Extranets are similar to intranet, except that they open all or part of the private network to allow sharing and collaboration with other organizations. Oh, okay. Never mind. I was completely wrong. The company only. Okay, so the intranet can only be accessed by the company only. Members of the company. It's restricted. Only certain people have access to the intranet. The extranet is it's open. It's not only just a company, but it's also suppliers, customers, and collaborators. So you would say that the extranet is my plain example. That's what would be an extranet because they're customers. They can pay to get service, like access to the Wi-Fi. So the extranet would, like American Airlines would be hosting their own extranet. I could be wrong though. I'm not sure. Going to Reddit. Reddit always sounds like a good example. Okay. I think my example isn't good. Intranet as a networks of your company where you and your colleagues have your computer on, while extranet contains the mail gateways and the web servers of your company so that these services can be accessed from everywhere on the internet. So are they saying that, say that Google opened up one of their servers to the open, that would be an extranet? Because now I have access to all these other servers, possibly, if they're open, if Google allowed them to be open. The intranet is just a network, but it's inside of a company. So only certain people have access to that network. Okay, I think I get it.
This is the internet. The internet is a wire, actually buried in the ground. It might be fiber optics, copper, or occasionally beamed to satellites or through cell phone networks. But the internet is simply a wire. The internet is useful because two computers connected directly to this wire can communicate. A server is a special computer connected directly to the internet, and web pages are files on that server's hard drive. Every server has a unique Internet Protocol address, or IP address. Just like a postal address, IP addresses help computers find each other. But since 72.14.205.100 doesn't exactly roll off the tongue, we also give them names like Google.com, Facebook.com, or SecurityCatalyst.com. So this is how it works. Your computer at home is not a server because it's not connected directly to the internet. Computers you and I use every day are called clients. because they're connected indirectly to the internet through an internet service provider. Here, we'll pretend that this is my home laptop and I'm using DSL. Now let's pretend that I want to visit AOL.com, which is coincidentally both a server and an ISP. I hop onto my laptop with DSL, go through my ISP onto the internet, and look at AOL.com. My computer connects with AOL.com, and I can look at its web pages. Now, let's say that I want to send an email to Aunt Ruth. Aunt Ruth has AOL dial-up from home, and I've got a Gmail account. I log on to gmail.com and compose a message to Aunt Ruth's email address, auntruth@aol.com. Once I click send, gmail.com sends the email to AOL.com. The next day, Aunt Ruth dials into AOL servers and retrieves the email. Whenever an email, picture, or web page travels across the internet, computers break the information into smaller pieces called packets. When information reaches its destination, the packets are reassembled in their original order to make a picture, email, web page, or tweet.
And how they're able to organize a picture into the same order is by using a protocol called TCP. You see, each packet has its own number, and it's basically just like a sorting algorithm. Like this packet right here could be labeled 1, so it'll be 1, 2, 3, 4, 5, 6, and obviously each packet would have its own ID, so they could be identified correctly. But there's also another protocol called UDP, which says, I don't care, and just puts it everywhere. I think YouTube uses UDP for its video stuff, but I'm not sure. I think it would make sense because, say that's buffering. Like it just stops, it's like slow down. I'm not sure. I think it actually uses UDP. I've heard it from somewhere that YouTube uses UDP for its video stuff. I'm not sure though.
Okay, so imagine you're at work sitting next to your boss, and you're both surfing online. Your boss is doing market research, and you're updating your Facebook profile. You're both sending packets back and forth over the internet. But what's to keep your packets from accidentally ending up on your boss's screen? That could be embarrassing. The solution to that problem is IP addresses and routers. Everything connected directly or indirectly to the internet has an IP address. Everything. That includes your computer.
Wait, what was that? Everything?
Could be embarrassing. The solution to that problem is IP addresses and routers. Everything connected directly or indirectly to the internet has an IP address.
Okay.
That includes your computer, servers, cell phones, and all of the equipment in between. Anywhere two or more parts of the internet intersect, there's a piece of equipment called a router. Routers direct your packets around the internet, helping each packet get one step closer to its destination.
Okay. That makes sense.
15 routers may help your packets find their way to and from your computer. Imagine each packet as a piece of candy wrapped in several layers. The first layer is your computer's IP address. Your computer sends the packet to the first router, which adds its own IP address. Each time the packet reaches a new router, another layer is added until it reaches the server. Then, when the server sends back information, it creates packets with an identical wrapping. As the packet makes its way over the internet back to your computer, each router unwraps a layer to discover where to send the packet next, until it reaches your computer and not your boss's.
So it's because of the IP address that it's not able to send it to a different computer. And that wrapping that they use, I think that's the OSI layer. The application layer, there's also a physical layer. And this is how the packet is wrapped until it gets to the physical layer and it's going through the wires. So here's a good example. So application layer, the data. Presentation layer, we wrap it. Session layer, we wrap it again, and so forth. And then we send it to the physical layer. And then it reaches this physical layer. Then it starts unwrapping it, like in that example, once it arrives at its destination. So say that the receiver was google.com, and we requested that we want to get an image like this. Well, this goes to google.com, this URL, goes to that server, and it pieces together this. We get the data, that's what we want, so we'll break it into multiple packets of this image, and it'll do all this, and then we send it over to the physical layer, and then it goes through the wire, then it starts unwrapping data link layer, network layer, transport layer, session layer, presentation, until eventually the application layer, which is Google, this right here, this web page. And then we see this image. There was also another fascinating thing they talked about, was that routers are the things that help you get to your destination. And I wanted to play around with something to see an actual packet get to where it's going. So I think ping or maybe route. I'm not sure what the tool is, but let me go on ping. TC route. Network. I don't know the exact name, and I'm probably gonna look it up pretty soon. Trace route, that's what it was called. Okay, I'm gonna send a packet to Google. So we're gonna do trace route google.com. I don't even have it installed. So it took 12 routers to get to my destination. This is my router. This is another router. This is the ISP's handle it now. And then it gets here to here. But yeah. And remember that google.com, that's just a domain name. It really is just an IP address that's a computer that's connected to the internet. That's where a DNS server comes in. A DNS server is basically like this huge hash map or a dictionary that maps a name to the IP address. It's more complicated than that, but that's how I picture it. So yeah, we can actually see it here. Google.com has this IP address. So we can click on this and this will direct us right to Google. Oh man, I guess not. Well, continue to this. Ta-da, we're at Google now. So yeah, this is a computer or a server, and this is another server, and all of these have an IP address. My computer has an IP address. So, yeah. You know, I always got web server confused. Maybe I don't understand it completely. It's just weird to me. Web server. Okay. Okay. Oh wait, I'm a little distracted. Oh, it was past my time. Okay, relax. Kind of curious on what all this is. And I'm thinking about, I'll probably like just skim through it. Just because reading all of this would take forever and I probably don't need it. Yeah, I don't really need any of this. So I'll probably get to the project tomorrow, because I can just go through these easily. CSS as well. Yeah, I'm gonna blow right through this, because I want to get to the JavaScript section. That's where the real meat is. That's where you do 3 projects. Huh. They even have a spinner. Oh, that's what I was gonna do anyways. So let's just start marking stuff that yeah, we've already done that. Landing page. I'm gonna go over and beyond for the projects, and I'm gonna use front end mentor for a lot of them, because I think front end mentor has a rock paper scissors game and a landing page. So you'd have multiple landing pages. Where's the rock paper scissors one? Here it is. And yeah, I'll just do that. And I'll just go right through it. Problem solving. Okay, I have a good idea of what we're gonna be doing now. So yeah, we're gonna make excuse me, the pace is gonna be a little quicker now tomorrow. So just to update you guys, tomorrow or today we're going to finish all of this stuff and finish to get basics, and then tomorrow we're going to finish all this stuff and possibly finish the recipes if I have enough time. And next day, so July 10th, we'll finish these two. And then July 11th, July 11th, I'm thinking about doing a 24-hour stream. Yeah, 24-hour stream of me, or not really, but a stream that is no. I'll do that for the final project. I'll do a 24-hour stream for the final project of the Odin Project. So that is this. And you probably seen like, oh, he's already completed some. Yeah, but I'm not gonna just copy my code and just like skip it. If it's like valuable information that I want to do again, then yeah, I'll do it. But yeah, I've done a lot of Ruby, and I've also done a lot of the Node. I've just deleted it because I didn't see it as useful for me. But for you guys, I'll do it. Okay, so let's resume. And let's make this .30 minutes. A search engine is basically just a crawler. It's a web crawler and just gets links. Yes, it's more complicated than that, but it's really just that. That's what a search engine is. A web page, a document which can be displayed in the web browser. Okay. Website, a collection of web pages which are grouped together. That makes sense. This is a website. A computer that hosts a website on the internet. Okay, I get it now. Oh no, this would be a web page, but Mozilla itself is a website. Mozilla has its own web servers that are hosting the website on the server. The library is like a web server. It has several sections which are web server hosting. The different sections, science, math, history, in the library are like websites. The books in each section are like web pages. One website may have several web pages. So yeah, I was right. Mozilla itself is a website, but it has multiple web pages. No, I was wrong. Web pages can be found at a unique location or URL. So this is a web page. This entire thing is a web page. They just made it more complicated. Let's look it up. Like, this image, I thought that was it, but weird. I want to figure this out. Guess I'll just read this. Web page in the mail as a single document or page that is displayed in the web browser. Okay. Okay, this right here finally made it click. So what I was saying was right. Mozilla.org. This right here is a website, and it contains multiple web pages via links. Okay. So, deeper dive. A web page can embed a variety of different types of resources, such as style information, CSS, JavaScript, the media stuff. A website is a collection of linked web pages plus their associated resources that share a unique domain name. Each web page of a given website provides explicit links. So I can go to a website called developermozilla.org. I'm on a website now. Well, actually a web page. It directed me straight to a web page. I'm on a different web page, and I can click here. I'm on a different web page now. A web server is a computer hosting one or more websites. Hosting means that all the web pages and their supporting files are available on that computer. The web server will send any web page from the website it is hosting to any user's browser per user request. Don't confuse websites and web servers. For example, if you hear someone say, "My website is not responding," they're talking about the web server. More important, since web server can host multiple websites, the term web server is never used to designate a website, as it could cause great confusion. So a web server is just a computer that's hosting our website. It has all the documents, it has all the media. So for instance, it has our index HTML, our CSS, our JavaScript, our any media like pictures, PDFs, CSVs, any of that information that's on our web server, and that we're going to use that for the website. And they also say that a web server can host more than one website. So it could host my portfolio, but also a blog and some other things. So a web server just has all the information for the web pages, or has all the documents for the web pages. Okay, I understand now. So let's try to explain it. So my thinking, or how I think about it, is that Mozilla, Google.com, Firefox.com, YouTube.com, Nike.com, those are all websites, and those websites contain web pages that we can click on. So for instance, Nike.com could have a shoes web page. We click on that, and then the browser will show us a web page showing shoes. So it has documents like pictures, HTML and CSS from the web server, from Nike's web server. That web server contained all the necessary information for that particular web page. It's dynamic. What does that mean? Well, a dynamic web page and not a static one would show different media. We don't want to see the same shoes each time. We want to be able to change it. Say that I wanted to show all the pink shoes, or maybe all the blue shoes. I could just filter it and get the shoes that I want to see. That's a dynamic web page. So on the Nike website, we could also go to a different web page. And Nike could also have different websites that could be hosted on Nike servers or web servers. And the only way we got to this website was because of a search engine. There's multiple search engines. There's probably even some open source search engines, but the popular one are DuckDuckGo, Google search engine, Firefox. Oh, I don't think Firefox. Well, I think it does. I'm not sure. No, it doesn't. So yeah, there's Bing and also Yandex. I don't know what this one is. I've never used Bing. I've used Google and DuckDuckGo. But think of a browser as the canvas, I want to say. It doesn't really do any searching. It only just paints what has been requested. So if you request shoes on a Nike webpage, then the browser will paint that information or those documents using the HTML, CSS, and JavaScript as a reference. I didn't really like the analogy. It confused me more. I would say that each book is a website, but if you open a book, then each of it is a web page. And you can search through the books by using a search engine. And the browser is just the book cover. It's not a one-to-one analogy, but that's how I think about it. Um, I wonder if there's some open source search engine. I know there's MilliSearch, but I don't think you can incorporate that into Firefox. Yeah, this is more used as like a library or an SDK that you can use for your website. Oh, here's a good example. Search engine. You're searching. You're searching for things. It uses a web crawler. But I don't think there's one. Probably is, but I just can't find it. Okay, how the web works. Clients are the typical web users' internet connected devices. For example, your computer connect to your Wi-Fi or your phone connect to your mobile network, and web access and software available on those devices. Usually a web browser like Firefox or Chrome. Servers are computers that store web pages. Oh, you should probably say web servers. Okay, never mind. Servers are computers that store web pages, sites, or apps. When a client device wants to access a web page, a copy of that web page is downloaded from the server onto the client machine to be displayed in the user's web browser. Yep, like we discussed earlier. The other parts of the toolbox, the client and server we described above, don't tell the whole story. There are many other parts involved, and we'll describe them below. For now, let's imagine that the web is a road. On the other end of the road is the client, which is like your house. On the other end of the road is the server, which is a shop you want to buy something from. In addition to the client and server, we also need to say hello to your internet connection. That was the router and the modem to the ISP. Allows you to send and receive data from the web. Is basically like the street between your house and the shop. It's like that wire, that big wire that were discussed in the YouTube video with the AOL. The TCP/IP protocol that define how data should travel across the network. This is like the transport mechanism that let you place an order, go to shop, and buy your goods. Yep, I was going to use the same example too. It's like a car that gets from this street to the other street, to our house to the shop. Which is more reliable? A TCP would be multiple mini cars, like small cars. So imagine that road and imagine this car. There's 7 of these cars, or 7 packets, and they're going down the road to the shop. Each mini car or smart car has a number above it that tells you the order. So they don't have to arrive in the same order, but once they do arrive to their destination, TCP or the protocol knows that, hey, okay, these have a number, these have an order. What's the order? And they'll look on top of the smart car and you'll be like, oh, okay, you're 5, so I'm not ready for you yet. I need 3 actually. Then I'll go to 4, then 5, then 6, and 7. Then it's done. Now UDP, it does not care. The UDP protocol is going to be like, oh, you're 6? Fine, go. Oh, you're 10? I don't think it would do that, but yeah, 7 packets. It doesn't care about the order. I don't even think it would have a label on it. A domain name system is like an address book. Oh, this is a perfect analogy. Yes, it really is just like an address book. It connects names to phone numbers or IP addresses to domain names. But for some odd reason, a domain name is way more complicated. There's like this king domain name or whatever. It's weird. The HTTP protocol defines a language for clients and servers to speak to each other. This is a language you use to order your goods. Component files. Assets. Yep, okay. When you type a web the browser goes to the DNS server and finds the real address of that server that the website lives on. The browser sends the HTTP request message to that server asking it to send it sends a GET request. Remember, it sends a GET request, not just some HTTP request. That method matters because it could be a post request or a put or a create, or I think put and create are the same thing. But yeah, this sends a HTTP GET request to the server asking it to send a copy of the website to the client. This message and all the other data sent between the client and server is sent across your internet connection using TCP/IP. If the server approves the client request, the server sends the client a 200. Okay, this is your status code right here, which means, of course, you can look at that website. Here it is, and then start sending the website's file to the browser as a series of small chunks called data packets. The shop gives you your goods, and you bring them back to your house. The browser assembles the small chunks into a complete website and displays it to you. Order in which component files are parsed. When browsers send requests to servers for HTML files, though HTML files often contain link elements referenced or contain links elements referencing external CSS style sheets and script elements referencing external JavaScript scripts. It's important to know that the order in which the files are parsed by the browser as the browser loads the file. The browser parses the HTML file first, and then that leads to the browser recognizing any link elements referencing to external CSS style sheets and any script element reference to scripts. As the browser parses the HTML, it sends requests back to the server for any CSS files. It has found from links elements, and any JavaScript files it has found from the script elements, and from those then parses CSS and JavaScript. The browser generates an in-memory DOM tree from the parse HTML, generates an in-memory CSS structure from the parse CSS, and compiles and executes the parse JavaScript. I've never heard of this term before. As the browser builds the DOM tree and applies the styles from the CSS tree and executes the JavaScript, a visual representation of the page is painted to the screen, and the user sees the page content and begins to interact with it. Like I said before, the browser is painting the screen. It's a canvas. The browser is just comprised of some matrix transformation, some computer graphics. It's basically just a huge computer graphics project. And a project that consists of parsing HTML, CSS, and JavaScript and interpreting it. Like you have to interpret the CSS. Like if it has a background color, you better make sure that your software understands that what CSS is asking for. That's what a browser is. DNS explained. Real web addresses aren't the nice, memorable strings you type into your address bar to find your favorite websites. There are special numbers that look like this. This IP address. This is called an IP address, and it represents unique locations on the web. However, it's not very easy to remember, is it? That's why the domain name system was invented. This system uses special servers that match up a web address you type into your browser, like mozilla.org, to the website's real IP address. Websites can be reached directly with their IP address. You can also use a DNS lookup tool to find the IP address of a website. So we can actually do that right now. I'm not sure, but I think it's dig.com, and here's the IP address. And we can copy this. We're gonna get an error from Firefox. Oh, never mind. But here it is. You can use a tool called dig, and essentially this will find the matching IP address for the domain name. I think I'm gonna make a tool like this as well in Rust, because there's some RFC that you can follow, and which will make it easier to build. There's some documentation that you can follow. RFC dig command. I think it's right here. RFC 1918. But yeah, we could look at that and do the project. Future stuff though. Packets explained. Let me drink some water. Earlier, we used the term packets to describe the format in which is this on? Okay. In which the data is sent from the server to the client. What do we mean here? Basically, when data is sent across the web, it is sent in thousands of small chunks. There are multiple reasons why data is sent in small chunks. They are sometimes dropped or corrupted, and it's easier to replace small chunks when this happens. Additionally, the packets can be routed along different paths, making the exchange faster and allow many different users to download the same website at the same time. If each website was sent as a single big chunk, only one user could download it at a time, which obviously would make the web very inefficient and not very fun to use. I would like to see it though. I wonder if I can create some software that can mimic that. Send in just one big packet instead of small chunks. I need to reread this one. Okay, this is another key thing to remember when it's dropped or corrupted. Say that we're using a TCP/IP protocol and packets have arrived at the destination, but we're missing one. Well, what TCP would do is that it'll send a request back to the client and say, "Hey, I'm missing a packet. Resend it," and then the client would resend that particular chunk. TCP protocol is really, really smart. You're always guaranteed to get the same packets in the same order. It's guaranteed. Yeah, here's the response codes. So we got 200 OK, 301, 501. This is your 404. So those are response codes. I also have another project in plan. We're going to be making the HTTP protocol. Because I want to learn how it actually works. But yeah, I think we understand so far. I'm going to do like a big explanation of everything we've learned when we're done with reading this one last article or web page. Domain name. Oh yeah, I totally forgot. You can use who is. I don't have it though. Crap. Look at all those bytes. So much more. This is going to support quintillions of computers, man. Like whoever made this was really thinking ahead. Because we're way out of IPv4. And we've made a mess of it. Once we ran out of this, we just started saying, "Oh, we need to apply some bandages to problems that we have because we've ran out of IP addresses." But we need to transfer all of our IP address to IPv6 like now or yesterday, so we can throw this out and just work on this. Actually, there's, I think, I wouldn't say a big portion, but a portion of it is taken away for IPv6. Like, not all of it's available, not the quintillion of it, which is weird. Oh well. A domain name has a simple structure made of several parts, separated by dots from or in red from right to left. So top level domain name, sub level domain name. Okay, secondary level domain name. Holy crap. Subdomains. For any domain you control, you can create subdomains with different content located at each. How do I do that? Do I have to also buy more domains just to get a subdomain? Nice. Still not a perfect system though. Because yeah, a lot of domain names are taken, and if they do sell them, they can price it for thousands of dollars. Like, say that I had the domain name Google before Google could actually take it. I would charge them billions of dollars. Okay, let's install Whois. Oh shoot. Wrong password. Whoa, that's a lot of information. Whois. I'm gonna look at my portfolio. Who is bubblebutt.org? Someone registered that? What the heck? Fabulous. Their email is fabulous. It's probably some like e-commerce place. Oh boy. I wonder if someone took this a funky domain name. I'm pretty sure someone did. Yep, someone did. What'd I say? People. It's not even used, is it? Yeah, I'm not going on there. Yeah, you can go on Google Domains, which is openly registrar. I don't know how to pronounce it. Registry. I'll just say registry. A funky. So I'm gonna make. We'll say whiteboard. It's taken, but say that we want to make a new domain. We'll go here. And we'll pick a top level domain that we want. It could be tech.com is taken, which is the most popular one. What about Scribble? This is what I mean. .com. And you have to pay $5,800 aftermarket. I don't like that. Oh my, come on, man. But yeah, you would do that. But one thing I want to know is how can I then connect my domain name to my website? Oh, I guess it's actually pretty simple. I got to think about that actually. Never mind. So my web server would have all my documents, all that information. And the web server itself would just be an IP address that could be masked as something else. So because a domain name is just really an IP address, so you could say that, okay, well, you're at this this is the IP address for this server. Now give it a name and it'll be that name. I think that's how you set it up. I'm definitely going to experiment with that. We're probably going to build some like simple website and then try to do all the back end from scratch without using any hosting services like Netlify. We're going to try to do it from scratch. Authoritative name servers. This is what I mean, not king. DNS databases are stored on every DNS server worldwide. if it already recognized the IP. Hmm. Authoritative DNS servers. So now the request is going through the physical layer. So this will be a packet. And this will go to the DNS server. Oh, okay. The resolver server is usually your ISP. Where to locate the root server? So, what the heck? What is it called? Is it a DNS server, or is it, or a DNS server and root DNS server the same thing? Oh. and it's kind of just like a filter. I don't know where this domain is, but I know its top level domain is .com. So go here, take this path, and it'll be quicker to find it here. A.root server. This is awesome. I really love this comic. Wait, how many episodes? American Registry for Internet Numbers. Trying to figure out what this information is. So I noticed DNS simple. So maybe I'll just do dig dnssimple.org. No, it's .com. Nice. So the root server told you where to find the .com server, and then the top level server or the .com server told you where to find authoritative name servers, and then the authoritative server gave you the IP address for a DNS simple or dnsimple.com. Then you go back and voila. That was a fun comic. I'm actually going to save that. I may have to review that later, to be honest. Okay. Now, we should have probably watched it as well.
That DNS is this important? We all know
Oh, because it's just like a file system. So if I go to projects, let's say that I go to a path and I type in dot. I'm at the root. Well, shouldn't it be a slash? It's weird. It should be a slash. Hold on. So resolving namespace server or resolving name server. View DNS cache. So we can actually just view it. So cat var cache host. I don't know. I don't think I'm using NCSCD. So this is what I meant by in memory. So Firefox is just a program and it's taking up some memory. You can see this by just pressing top. It's been allocated this block of memory. I guess virtual memory. So virtual memory 13.1 gigs. I don't know about that. But yeah, it has some memory, and its domain names are in cache. I can clear this and start the whole process again. But since it's in memory, it would just quickly just go to this one. So it doesn't have to do all that hard work again.
For the sake of this demonstration, it does not. The only thing that all resolving name servers should know is where to find the root name servers. Yes, that enigmatic dot that appears at the end of every domain name you type into that address bar. The root name servers will reply with,
I don't know, but I do know where to find the com name servers. Try that.
the com name servers are called the top level domain name servers, or TLD name servers. The resolving name server then takes all of this information from the root name servers, puts it in its cache, and then goes directly to the com TLD name servers. When the resolving name server queries www.example.com, the TLD name servers respond,
I don't know, but I do know where to find the example.com name servers. Try there.
This next set of name servers are the authoritative name servers. So how did the ComTLD name servers know which authoritative name servers to use? With the help of the domain's registrar. When a domain is purchased, the registrar is told which authoritative name servers that domain should use. They notify the organization responsible for the top-level domain, the registry, and tell them to update the TLD name server. So, anyway, the resolving name server takes the response from the TLD name server, stores it in cache, and then queries the example.com name servers. At this point, the authoritative name server will say, hey, I know where that is. Tell your browser to go to the IP address 192.168.1.1. Resolving name server takes this information from the authoritative name server, puts it in cache, and gives a reply to the operating system. The operating system then gives this to the browser, and the browser then makes a connection to the IP address requesting the webpage for www.example.com. Pretty cool, huh? While the process seems complex, and believe me, it is, this whole cycle takes less time than it takes you to blink an eye. DNS was designed to work extremely fast and efficiently. It's an integral part of the internet. Once you understand this, you can clearly see the many different facets and organizations that are responsible for a single DNS lookup. One lookup! There's a resolving name server, the root name server, the TLD name server, and the authoritative name server. If anyone were to servers and the authoritative name servers.
Solving root, TLD, authoritative name servers. I'm thinking, what would it take to build my own dig? I would have to handle my own cache for dig. Well, maybe not. I don't know. Could probably just have like a database for it. That'll just be my cache. But yeah, my operating system will go to the resolving name server, and then my resolving would ask root name server. Then it'll save something, so it knows next time. And the resolver will go to TLD. TLD would tell the resolver to say, hey, I know where the authoritative name server is, and authoritative, or no, it's the TLD that has a registry.
Resolving name server takes the response from the TLD name server, stores it in cache, and then queries the example.com name servers. At this point, the authoritative name server will say, hey, I know where that is. Tell authoritative. The resolving name server then takes all of this information from the root name servers, puts it in its cache, and then goes directly to the top TLD name server. When the resolving name server queries www.example.com, the TLD name servers respond,
I don't know, but I do know where to find the example.com name servers. Try there.
this next set of name servers are the authoritative name servers. So how did the ComTLD name servers know which authoritative name servers to use? With the help of the domain's registrar. When a domain is purchased, the registrar is told which authoritative name servers that domain should use. They notify the organization responsible for the top level domain.
So I ordered a domain name, and Google owns them. So the registrars are from, or maybe not, Dyna Dot. Or I guess this is the registrar. Okay. And that's from the no, not the authoritative, but I forgot the name already.
Domain is purchased. The registrar is told which authority
Yeah, registrar. Okay. I've watched all the video. What is a web server? Web server is just a computer, a specialized computer that has web pages, documents, assets that a client can request to appear on a browser. For instance, a web server could have just static files, HTML, CSS, on its web server for a website called example.com. The user will send a request to that web server using the TCP/IP protocol, and the server will send a response back to the client, giving it the documents that it needs for the web page. So if the web page is, or if the client is on example.com and on the first route / then it will get the necessary documents so the browser can paint all the HTML and CSS. What is a network? A network is a way for computers to talk to each other. What is the internet? Or I guess no, a network would just be I don't know. Oh yeah, okay, I was right. Yeah, it just allows for connection between two or more computers. What is the internet? The internet is the foundation that allows for global communication for computers. They allow computers to actually talk to each other. What is an IP address? It's an identifier that every device has that connects to the internet. What is a router? A router is a computer that allows other computers to connect to the internet via a modem. But a router is also a way to direct traffic. So for instance, if we have 5 computers all connect to a router via Ethernet cable, then the router can intelligently determine where data would go. So if computer A requests or sends something to computer D, which is all on the same network, then the router can determine, like, okay, well, computer A has this IP address, it wants to send something to this IP address. It will send that data, that packet, to computer D. And what we also do with routers is that routers are all over the internet. It's what allows packets to travel. For instance, the previous example that I used for hops, if we run traceroute, we saw that there was 10 or 12 hops that a packet had to do in order to get to Google servers. Those are routers. Those hops are routers that is traveling through. What is an ISP? An ISP is just your internet service provider. They're the ones that provide your resolver, the internet, because your router just connects to a modem, and that modem connects to a telephone infrastructure. You get your internet from your ISP. What are packets and how they use to transfer data? Packets are just small chunks of the data, and they're transferred via the TCP IP protocol or UDP protocol, and they're sliced into small chunks of said data. So if you have a picture, it'll be broken down to thousands of smaller chunks of bytes, and it'll travel across the internet being wrapped, or it'll be wrapped first through the OSI layer, so that's application presentation, all the way to the physical layer, and then be sent through the wires until it reaches its destination, which is unwrapped and sent to the computer. But how does it know where to get it? Well, that's because of the DNS. We're sending a request to the DNS, so we know that we have to get the IP address, because every domain name has a DNS. Every device that connects to the internet has an IP address. So that's how we know that this packet goes here. He was right. A DNS server is really important. Without it, internet would not work. What is a client? Well, a client is just the one that interacts with the page. They, send a request and all that. What is a server? A specialized computer that's on 24/7 that has documents or web pages, applications, or whatever in memory, or I wouldn't say in memory, but it's on its hard drive. What is a web page? A web page is this is a web page. It's just the current HTML and CSS and JavaScript stuff that's on the current page for a website. What is a web browser? Well, that's Firefox. That's Google. It's the thing that paints your CSS, your HTML, and then JavaScript. It's the one that interprets all of that. What's a DNS request? It's a request to find the IP address of some domain name. Which browser are you currently using? Firefox. In other words, explain what happens when you run a search on google.com. So, here's a big learning opportunity. When I type in YouTube.com, I am sending a request to YouTube servers. But before that happened, Firefox will go into its cache in its memory, and it will find the IP address of youtube.com. Once it finds that IP address, it will then send the packets of the HTTP protocol. So, for instance, this is what it will look like if we do a curl v youtube.com. We're going to be sending this packet to actually, hold on. Verbose data from curl. I guess I did. Oh no, it's capital or lowercase v. So here's what we're sending to, or here's the packet essentially. It'll just be in hexadecimal or zeros and ones. Trying to get this IP address. So it's in cache and we already have it stored. Connecting to YouTube. So now we've arrived at our destination. Our packet was using TCP IP to travel across the network. It went through multiple routers to get there, and we sent this request. We sent a GET request using 1.1, and we sent it to this server using port 80, which is the HTTP port number. We said that, okay, we want to have some files or whatever for this website. So we get the web page, and the server will send that data back to our computer, to the client. So we didn't have to go through the resolver or the root server or the TLD com or any authoritative server, because Firefox already had it in memory in its cache. So we could skip that entire process. So that's what's going on. And you get a 200 response code, meaning everything went perfectly. Or I guess a 301. But usually it's a 201 or a 200 OK. Mark as complete. Actually, let's see an actual packet. We're talking about this, but let's see an actual packet. Let's see it travel. Okay. Dang, I do not have a lot of tools. Whoa, I don't know what the heck this means. Well, maybe I actually need to just run it with sudo. There we go. So let's see. Filter. Oof, I should probably not store my private IP or public IP address. IP adder. Okay, here it is. And then we'll just say if IP address equals this, and we send. So yeah, we're getting a lot of requests to my computer, but that's probably because of OBS, since it's using like a WebSocket and stuff. But I want to go on YouTube. So let's put this as a split screen. And let's go click on YouTube. So application. TCP. I've blown right past my Pomodoro. We can actually see the packet going through. And then or I guess it's this. I'm not sure. I gotta do dig 206. Oh, we got a different IP. But yeah, this is YouTube. And it's given us a response now to my computer. So yeah, that's a packet. Here it is. So let's go here. It's sending me a packet. Or no, we'll go here. Hypertext Transfer Protocol, HTTP. Encrypted. This would be the entire packet or frame. This is it. Like I said, it was bytes, and since it's hexadecimal, it can be represented as bits. But it's all encrypted, so we probably won't get it all. Maybe there's example. No, it's secure too. Okay, let's figure out. So the IP address for this. Should probably remove the protocol and all that. Okay, 142.93.84. Okay. Let's just do this. So this is a ACNAC crap, whatever the hell. This is a TCP stuff. And voila, we've successfully connected. And now Here's the same data. We couldn't see this with YouTube because it's encrypted. But here's the HTTP request that I talked about. This is it. This is in bytes, ASCII, and this is it in that an actual text. This is an entire HTTP request right here. It's a GET request. And now, Social Studies Help is sending a response back. And that's going to be some HTML. Well, I don't know if it's HTML. Maybe. Yeah, this looks like HTML. Okay, here we go. We got the entire thing. Boom. That's the entire packet right there. Probably did like one more acknowledgement, and then it said, okay, here's a response of all the HTML. And that's how it works. That was pretty fun. I actually learned something too. I learned how that HTTPS is actually pretty damn important. And I need to learn more about Wireshark. It would actually be useful in the future. Especially when debugging stuff. Okay. Command line. I'm just gonna look through this. I don't need this. Unless there's something really useful here. I don't need to go through any of this. Bash is just ugly. For loops and bash, man, so freaking weird. I won't learn anything here. I don't really like this book. And I don't really think I need to buy a book right now. But this actually looks useful. And it's open source too. Okay, let's take a little break. 30-minute break this time. My back hurts, so I'll be right back. I am back from my break and I'm ready. Feel refreshed, ready to go. Okay. So we're going to do this. Oh, I guess it's just like a one big readme. I thought it would be more like a interactive tutorial that you could go through. Okay. So we probably won't cover everything today, but we don't need to do this. That'll just be a waste of time for me. But we will answer these questions. So, what is a command line? Command line is just where you type commands in. How do you open a command line on your computer? Control-Alt-T. How can you navigate to CD? When will CD on its own navigate you to the home directory? Or $, capital H, capital O, capital, or just capitalized home? Where it'll jump you back to the parent directory of the current directory that you're in. How do you display the name of the directory you are currently in? ls. How do you display the contents of the directory you are currently in? ls. Make dir touch remove -rf or just just rm. How do you rename move? mv. How do you display it? I feel like file? No, it's for a directory. You would use freaking ls or -d or for something for directories. I'm not even going to attempt to read any of this because you'll just forget it. Said, oh boy, that'll take a couple of months to get really comfortable. I shouldn't say a couple of months, but a few weeks. Said is just weird. Tried learning it, it's just my brain could not comprehend what was going on. Processes. What the heck? Is this just a grep tool? Why would you use this then? Just use grep. Okay. So let's go through these two and then we'll finish up with this. just skimming through this stuff. Ooh, MTR, Google. Wow. Wow. That is cool. Now we're getting to linkers, strace. Cool, cool, cool. Actually, this doesn't really... Hex edit. Whoa, what is that? This is more as a reference than anything. Curl cheat. Got a little hiccup. Okay, we're back online. So if I do tar, do a little curl or a request, we get this. That is freaking cool. Nice. Let's see. Anything else? Not really. Okay. However, save and get records differences in the files and folders and keeps a historical record of each save. This feature is a game changer. As an individual developer, Get enables you to review how your project grows and to easily look at or restore file states from the past. Once connected to the network, Get allows you to push your project to GitHub or other alternatives such as Bitbucket, Beanstalk, or GitLab. Beanstalk. Get is a version control system. Get allows you to commit some changes, push it, but you're able to go back to that change. A text editor will just save it. I don't think it will allow you to go back to a commit that you made 5 years ago. Does Get work on at a local or remote? Both, because you can host your own Get repositories. You can have a website and you can put your own Get stuff. Does GitHub work at a local or works at a remote? Why is Get useful for developers? Because it's like the article says, like a big save button. Without it, we would have to do so many rough drafts or like draft files, and that could just be hectic. That's why Linus Torvalds created it. He wanted a better way to manage Linux or the kernel. Why is it useful for a team? Because they're able to work together. Like, hey, I committed this, I pushed it. Okay, now this person can retrieve that work and start working on it. Because it's really great for working on a team. Well, the merge conflicts aren't as fun, but yeah. I think this is remote. I forget. Okay. let's see. Get config. Yeah, I don't have to do this. I've created enough repositories where I know what I'm doing. Okay, get best practices. There's a lot to learn about Git, but it's worth taking the time to highlight some of the best practices. 2 helpful best practices to consider are atomic commits and leveraging those atomic commits to make your commit messages more useful to future collaborators. Atomic commit is a commit that includes changes. I need to get better at doing this. Atomic commits are something I do, but sometimes I'm so indulged into my work that I make multiple changes throughout the source code. So I tend to use get I tend to like commit chunks. I forgot what flag it is, but Git has this feature where you can like chunk certain changes you've made, and that's what I tend to do. But I usually forget the changes I made, and it just complicates things. It sucks, but hey, oh well. I'll get better. I'll definitely get better at that. How do you create a new repository on GitHub? You click on a new repo. How do you create a repository on your local machine? Get init or get clone. You can actually do twice. Get init to create or initialize all the files you need, the .get directory, or you could just do get clone and that repository from GitHub that you made. What is the default name of your remote connection? I don't know what you mean, but not main. That's the branch. Is get at whatever your repo name is. I don't know this one. Explain what origin is in the GitHub get push origin main. Origin, I don't know this one. I used to, but I forgot. Your main is your branch. Explain a two-stage system that Git uses to save files. So get add and then get commit. You do a get status. How do you add files? Get add and then the path or the files you want to add. Or you could also just leave it blank and it'll just add everything. How do you commit the files in the staging area and add a descriptive? So get commit -m and then your message. How do you push your changes to your repository? Get push or get push origin branch, or you could just do get push. How do you look at the history of your previous commits? Get log. Okay, so what does this mean? Oh, I never knew that. So let's go to I-80. Which is the name of your remote connection. Oh. So I just did a get remote on one of my existing repos, and it has different names. So development, which is the name for this URL. And there's also origin and staging. That's the name of my remote connections. Gotcha. I definitely need to get better at Get though.
You can see 5,900. So you can see, don't worry about what these things represent. We'll cover into it later on. This is basically the history of the project that I was talking about. History of the project, as you can see. So basically, this person made these changes in the code base. Red means that this line was deleted. Green means that this line was added. So this person 9 days ago made these changes in this file. So you can see the history of the project. And this how do we get this .git right repository in my project folder? Now you might be asking me, hey Kunal, I can't see anything over here. How are you so sure you will not enable? You can also decide about what they about in project to create a new file, another Linux command you play out. So I'll be like, hey photographer, please no. This hit is we will and you have a few lines of code that you are working on. Now you want to try out something new with a clean code base. Okay, all the changes that you have been made that are work in progress, files you have been modified, you want to remove those, but you also don't want to save your progress as a separate commit. You basically want, hey, I wish there was a way where I could just put all my work somewhere else without making a commit, without making a history in the project, and whenever I want that thing back, I can get that back whenever I want.
Oh, is that a get stash?
Get stash.
Okay.
Basically get the people you want to be on the backstage first on the stage. So it says this file was deleted, this is a change. Now I'm going to get stash this. I'm going to say, hey, go back to the staging.
I don't think I need this. Okay. I know there wasn't a lot of material, but that kind of just marks the end of this live stream. Yeah, so for tomorrow, we're going to finish this entire thing. HTML foundations. We're going to finish the entire thing. This is going to be just like yesterday. We're going to just skim through the material, because this isn't the real meat of where I should be. But yeah, I think that's good for now. This is a reference, so I probably won't be going through this in the stream. Just give me some pointers to look at, and that GitHub tutorial, it gave me some useful tidbits of things I should refresh on, like rebase. Totally forgot what that does, but I digress. But yeah, I think that's the end. I'll stop right there. So bye everyone. Whoever came, thank you for coming. It's been real nice having y'all. Peace.